Hello, this is Mr. McLeod, and I'm going to be doing a little demo on abstract classes. So if you're wondering, well, what is an abstract class? An abstract class is a class that represents a general type of object that is so general that the expectation is that you will always have some more specific subclass of this type. Right, so a great example is actually provided in the Greenfoot system. If you were to look over at the actor class is an abstract class, right? And if you think about it, to make a Greenfoot program, generally you have to make subclasses of actor. You can't just add actors to the world. You can't just say, hey, new actor. And in fact, the compiler will enforce that because it is declared abstract. Okay, but it also just wouldn't make sense, right? Like, what kind of actor is this, right? Actor is just too general a term. Same thing applies with the world class, right? Every Greenfoot program has to have a subclass of world, right? Because world is abstract. All the classes that you guys have been making so far have been what are known as concrete classes. If a class is not abstract, that means it's concrete. And you can tell the difference simply by the key word here, right? When you declare a class, if you say abstract, then it's an abstract class. If you don't say abstract, then it is a concrete class. Okay. One of the advantages of abstract classes is that you can have what are called abstract methods, which are methods that you declare in the abstract class because you're expecting every subclass of this class to have such a method. But you don't really have a default implementation that makes sense because every class is going to implement it in some way, but the way that it implements it is varies wildly, right? So in that case, if you had an abstract class foo, right, you could declare a method do stuff, and you declare it by saying using the abstract keyword to indicate that this method is abstract. And then instead of curly braces, you just put a semicolon so that there is no implementation, right? The fact that abstract classes are allowed to do this is actually one of the very good reasons why they are not allowed to be instantiated, because if you are able to make an instance of foo, then what would happen when you call do stuff, right? It wouldn't know what to do, right? So that's a very good reason why you can't ever make an instance of an abstract class. Okay, so then let's say we have this abstract method do stuff. If I wanted to make a subclass of foo, okay, so over here, I'm going to make a subclass of foo named bar. And notice this one does not say abstract. That means it is not an abstract class. It is a concrete class, but it extends foo, and therefore it inherits this abstract method. So since it is inheriting this abstract method, and the method is abstract, so it does not have an implementation, then it is required that the subclass implement the method. In other words, implementing the method means overriding the method, which means redeclaring it exactly as it's declared in the superclass, except that it won't have the abstract keyword and it will have curly braces, right, instead of a semicolon. And then inside those curly braces, you can write whatever code you would like to run whenever do stuff is called on a bar, right? Okay, so very important thing to remember, because the moment you subclass an abstract class that has an abstract method, there will immediately be a compiler error that will tell you you need to implement that method or whatever methods are listed. Okay. So I'm going to do a little demo here where we're going to go through this process of actually creating an abstract class and create some subclasses of that abstract class. So what I'm thinking is that I will make a class that is designed to do various effects on the world, right, or on the actors that are in the world. So this is going to be a very generalized concept, so that's why I'm making it an abstract class. So I'm going to go over here to notice that I'm not clicking on actor or world. I'm just going to click on this white area down here below that is not on actor or world. I'm just going to say new class. And so that this is indicating that this is going to be a class. It is not a subclass of world or actor. Okay, so I'm going to call this, let's just call it like world effect. Okay, and this is going to be some effect that does something potentially to many things in the world, right? So exactly what it does is actually very open-ended, which is why I'm going to make it an abstract class. Okay, so I'm going to delete all this. They give you all this starter code. It's not that helpful in this case, especially. So I'm just going to delete all of this so that we can start clean. Okay, and then we're just, in fact, you know what? I'm going to completely erase everything. We're going to start completely clean. Okay, so the first thing we need to do is declare the class. So we would say public, and then we want it to be abstract. So we say abstract class world effect. Okay, and then we do the curly braces. Okay, so we now have this abstract class. And my idea is that an abstract, so a world effect is going to be able to be applied to a world. So it always has some world associated with it. So what I'm going to do is I'm going to make that be an instance variable. So I'm going to say private world. Okay. Notice this one is lowercase, right? Because it's a variable name, whereas this is uppercase because it's the name of a class. Okay. Now, first thing you'll see here is that actually it says, what the heck is a world, right? Sorry. So the reason it is asking what is a world is because we're writing this in a class that has not imported the Greenfoot package, right? If you remember when you made a world or an actor subclass, it always had at the top, it would say import Greenfoot.star. So what that was doing is importing all the classes in the Greenfoot package, right? So back here, if we looked at the Greenfoot API, we go back to package. So all of these classes, actor, color, font, Greenfoot, Greenfoot image, Greenfoot sound, mouse info, user info, world, all of these are part of that package. Okay. So we're going to go ahead and import. But you know, in this particular code, I'm not actually planning to access anything other than world. So I'm just going to specifically import greenfoot.world. I don't really need to import all of them. Okay, and that makes the compiler happy because now it knows what I mean by world. All right, so then I'm going to make a constructor. And my idea here is that world effects always have to have a reference to the world that they're going to do an effect in. And therefore, it won't make any sense to make a world effect that is not that does not have a world reference. So therefore, I'm going to explicitly define a constructor that takes a parameter. So I'm going to say public world effect, and the parameter it takes is the world that this effect is going to be applied to. Okay, so there we go. And my plan in this constructor is to simply, I take this world and I just simply save a reference to it. So now we have this little conundrum here where the instance variable is named world, and the variable, the parameter, is also named world. And my plan is to set the instance variable to the parameter. But if I do this, all I'm really doing is referring to this world every time, right? Because it is the most recently declared, most specific world, right? If I declare a local variable in here, I can no longer access this one by saying world. We can solve that by explicitly saying, I want to access the world property of this, right? If you remember, this was a keyword that refers to the instance of world effect that is being initialized in this constructor. Okay, so if I say this dot world equals world, that solves that problem. Okay, so previously you solved this issue by simply, naming this different, right? So if I did that, then that would also be acceptable. But I do want you to begin to be familiar and get used to the idea of the word this. So I'm going to do it this way for now. Okay, so then down here, I can declare methods that I want this abstract class to have. And abstract classes can have normal, fully defined methods, just like regular classes. And they can also have abstract methods. So we're going to give an example of each of these. So a good example of a fully defined method would be for the world class. Since I'm planning to make subclasses of world effect, and I wanted to make my world instance variable private, because my idea here is that once a world has been set for this effect, then that's it, right? The world that is being affected will always be that same world. Okay, so part of that is because I'm going to be planning to both add and remove effects, right? And I don't want a weird situation where I add an effect to one world, but then I remove it from a different world. That would create weird effects or unexpected results, I should say. So to protect my class from that unexpected behavior, I'm making the world private. Although just in general, you should always make instance variables private unless you have a good reason to not make them private. Okay, but also for that reason, I'm only going to have a getter. I'm not going to have a setter because I want this to be basically like a read-only attribute where you can find out what world the world effect is going to be applied to, but you can't change it. And that's also the getter is going to be critical for subclasses, because since this is private, that means even subclasses will not be able to directly access world. They will have to use the getter. Okay, so without further ado, let's go ahead and do this. So we're going to say public world, because the return type of the getter has to be the same type as the variable, right? And then I'm going to call this get world. It's not going to take any parameters, because all it does is return a reference to the world. There we go. Okay, so then I'm also going to make an abstract method. And this is basically the method that's going to define what does this effect do, right? So there isn't really a default implementation that would really make sense, because almost, every effect is going to do something. So making it do nothing is kind of weird. On the other hand, there's no common thing that they all do. So this is a perfect example of where you would want to make a method abstract, right? So we're going to say public abstract, and then the return type. In this case, it's going to be void, and I'm just going to call it apply, like you're applying the effect to the world, right? And then I'm also going to make so I can add a comment here that says, what will this effect do when applied? Okay, and then the other question I might have about an effect is, what will happen when the effect is removed, right? So we're going to define that in an abstract method called remove. Okay, so both of these are not really methods that I can define before I make the subclasses, because the subclasses could choose to do whatever they want in there. All right, and that's it. I've made my abstract class, and I'm ready to make some subclasses of the world effect that will actually do things in apply and will actually do things in remove. Okay, so let's go here. Okay, so now that I've made this world effect class, if I right click on it, I can now make a new subclass of that class. Okay, so I'm going to do that. And I think for my first effect, I'm going to make an effect that goes through the list of all the actors in the world and scales them by some scale factor. So I'm going to call this just scale effect. Okay, and hit OK. All right. So one of the things that you'll notice is the moment I make this subclass, instantly there are compiler errors. I'm going to delete all this extra stuff. Just again, it gets added automatically, and I don't need any of this. So there we go. So far we have public class scale effect, and it extends world effect. And you can see now I've hovered over the error. So you can see scale effect is not abstract, and it does not override the abstract method remove in world effect. That's actually only one of the errors. It actually doesn't implement apply either. And there's even going to be another error. So let's work through these errors. So the answer to all of these errors is to do the thing that wasn't done, right? We didn't override the remove method, right? So we didn't implement the abstract method. So we're going to go ahead and say public void remove, because that was the one it was complaining about. Okay, so I have to declare it exactly as the superclass declares it. If I were to spell it differently, then it's going to complain. Whoop, still doesn't know, right? If I try to change anything, like change this to an int, then it's going to complain. Wait a minute, nope, we can't do that because we already have one that's void, and you can't just change the return type like that. Okay, so anyway, once I've declared remove, then it's going to complain about the other one, apply, right? So we got to do both of them. Okay, so public void apply. All right. And now there's yet another error. And this error requires a little bit of explanation. If I hover over this thing, it's maybe a little bit confusing. It says constructor world effect in class world effect cannot be applied to the given types. Required Greenfoot.world found no arguments, actual and formal arguments lists differ in length. Okay, so it's very what it's really saying is that when you declare a class, if you don't declare a constructor, it will declare a constructor for you called the default constructor. Okay, if you do declare a constructor, it won't declare that. Okay, but if you don't, then essentially by not writing anything, the compiler writes this for you: public scale effect with no parameters. And then this is important. The first line of every constructor, if you don't write it, it writes it for you, is going to be super with no parameters. Okay, that's what it's going to write. It's going to try to call the default constructor for the superclass for you. So basically, it writes all this code for you, and then it complains that the code that it just wrote for you is wrong. Isn't that pretty funny? Okay, so basically, it writes all this for you, and then it says this is where the source of the error is, right? Is it's complaining that it's calling super, and that doesn't work. And if we go back to the world effect class, you can see that's because we declared a constructor that takes a world, and by declaring this constructor, it means the compiler is not going to automatically declare a default constructor for the world effect class. And in this case, we actually don't want it to have a default constructor, because that would mean you could make an effect that did not have a world associated with it, which we don't want. So the solution here is to explicitly call the superclass constructor that takes a world, right? But that also implies that we should, in fact, not have a default constructor for scale effect either. Instead, we should have a constructor that takes a world here as well, right? Now, as soon as I do this, it's going to do that complaint up here that I needed to import. And this time, I think I will do Greenfoot.star, because I'm planning to do a lot more than like in apply. I might use some of the other classes. So I'm going to go ahead and import them all. Okay, and so then in here, I've got this constructor that takes a world. And really, I just want this world, whatever world I constructed, whatever world was passed in for scale effects, that is the same world that I want to pass to the constructor world effect, right? So I'm going to say super world right here. And so then basically this world is going to get passed in to the constructor. And remember that super refers to the world effect class, because that's what class this class extends. So then if I go to world effect, then basically we're passing in this world, which then sets the instance variable world to be the world that we just passed in. Okay, so this is how this is working, right? It's like scale effects takes a world, passes it to world effects, and then world effect sets the instance variable to that value. Okay, so then the next time I call get world, it's going to return the same world that was passed in here as a parameter when I created a new scale effect, right? Because get world returns the instance variable world. Okay, so we've got the constructor taken care of. And this would work just fine if the only thing we wanted was scale effect, doesn't need any other information. In this case, I think I'm going to make scale effect actually have a property here, an instance variable that is going to represent how much it will scale. So I'm going to say private double, because it's going to be a decimal, and I'll just call it scale factor. Okay, and whatever the scale factor is, it's going to go through and scale all the images in the world, all the images of all the actors in the world to that by that scale factor. Okay. Okay. So that means that I probably want to. It's probably only going to make sense to create a scale effect if you also apply a scale. Okay, so there really isn't like a scale factor that like makes sense by default. So they got to send you something here. So I'm going to say double, I'll just call it factor this time. Okay, so then in this case, instead of having to say this dot scale factor, I'll just say, I can say scale factor equals whatever factor they pass in, right? Okay, so then, let's see. Yeah, that's good enough. I could make a getter and setter for scale factor, but I think it's fine. If they want a different scale factor, they would just make a new scale effect, right? So I don't think it's really necessary to get or set that value. All right, so in the apply method, I said that I wanted to apply, I wanted to go through to every actor in the world and scale them by this scale factor. So to get a list of all the actors, if we look in the Greenfoot API, if we go to the world class, there's this method right here, get objects, that takes a class object where the class that it represents is given by this A, and it returns a list of A, right? In other words, a list of that same type. So for example, if this said get objects ball.class, then this would be a list ball, right? A list of balls. Okay, in this case, we want a list of all the actors. So we could just say actor.class. So if we said actor.class here, then this would be a list actor. All right, so let's try that. Say list actor. I'll just call this actors equals, and then I need to call this on the world. And I also need to make sure that I include an import for this list, right? So up here, let's take care of the import right now. So import java.util.list. Okay, and then I need to call this method on the world. So I need to say, if I tried to just say world here, thinking that, oh, well, world effects have this world instance variable, I'll just try to access it. Once I get rid of all the other errors, it's going to tell me it can't access this world. So I'm just going to go ahead and show you there. So if I pass it actor.class here, okay. So then if I go to the error here, see this? It literally tells me exactly what I was saying here. World has private access in world effect, so I can't access it, right? So what I need to do is use the getter, right? That was why we made this method get world that returns the world. Okay, so I can say get world. This is very similar to, you can probably guess now that this is similar to essentially what happens in the actor class, right? And every actor has a reference to the world that it's in. And when you say get world, it returns the reference to that world. Okay, so we got our list of actors, and now we need to do a loop that's going to go through all those actors. So we're going to say for int I equals 0, I less than, and we want to get the size of the list. So if I were to go look up list API Java, I could go here to the list API, and down here, here's all the methods that lists have. And right here is a method called size that returns the number of elements in the list as an int, right? So that's exactly what I want. I want to go through all of these elements. So I is going to be the index as long as the index is less than the size of the list. Actors.size, then I'm good because the indexes start at 0. So if the list is size 2, that would be 0 and 1, right? So it's always one less than the size. Okay. So there we go. All right, so we've done a loop that goes through all the actors, sorry, all the indexes in the list of actors. So then to get each actor, I could say actor A equals, and then I need to get an item at a certain index. So let's go back to the list API, and it's probably going to start with get. So let's see, it's in alphabetical order here. Hey, there we go. In fact, it is get. So get, and then we pass it the index, right? And then you might be wondering, well, wait a minute, what is this E here? Okay, so way back here, it says that E is the type of elements in this list. Okay, and if you remember, we figured out, so E is basically just like this A right here, right? And we said if we pass it actor.class here, that means A is going to be actor. And I guess technically to know that, you would have had to look up the class. Let's go ahead and do that. Class Java API. Okay, if we go there, you can see this is a class that represents classes. And that's a little bit meta there. And you can see here, the T says this is the type of class that is modeled by this class object. And they give an example here, right? String.class is a class string, right? So you can see that if this was actor.class, it would be a class actor. Okay, so I think that's pretty clear now that going back to our code here, we made a list actor, so that's why the return type for get is going to be actor. So I can declare a variable of type actor. I'm going to name it A, and it's going to be actors.get the item at index I. There we go. Okay, and then now I said I wanted to scale each of the images of these actors by this scale factor. So all I need to do is get those images. So I'm going to say Greenfoot image img equals a dot get image. Okay, I think you guys are familiar enough with Greenfoot to know now that's how you can get the image. If you're not so familiar, you could go look in the actor class and you would find the get image method. And then that returns a Greenfoot image. And if we want to scale, we can again go back here to our Greenfoot API and go back to the list of classes. There's Greenfoot image, and go down the list here, and there's a method called scale that takes the new width and the new height that we would like the actor to be. So in this case, we want it to be kind of like the same shape, like the same aspect ratio, but we don't. But we want it to be. So basically, we're going to change the width and the height by the same scale factor, right? Just multiply them both by the same scale factor. So in order to do that, I'm going to make the new width, W is going to be, and there's one thing that we got to watch out for here. So let's go back to this here. If we look at scale, let's see, oh, well, that's too bad. It doesn't warn you about this. Probably should, but if you pass a number that is 0 or less for width and height, it's going to throw an error. So that includes 0, right? And one of the things we have to watch out for here is that, let's say the width was like 5, and I multiplied it by 0.1, then I'm going to get 0.5. Okay. However, I have to store this in an int. So if I store this in an int, I can do that by typecasting it to an int. Typecasting means go ahead and just do whatever you need to do to store it as an int, right? That's how typecasting to an int would work. And one of the things it would have to do from going from a double or a decimal to an int is it would just chop off the decimal. So now I'm left with 0, right? So that is a problem that I need to watch out for. If you have a small image and the scale factor is small, you could end up with a number that effectively gets truncated down to 0. So one way to handle that is essentially I want the width to never be less than 1. So I could just get the width first, and then if it's less than 1, just make it 1. I think that's probably the simplest way to do it. Let's do that. Okay, so we're going to say first the width is is going to be whatever the old width was, right? So image.getWidth times the scale factor. Okay, and if I just do that, then we get this error where it says, oops, this is a double, and we're trying to put it in an int. So possible lossy conversion, just basically saying, hey, you might lose data. If I'm okay with that, which I am, I have to put the entire calculation in parentheses. So to indicate that I want to do this whole calculation, and then whatever the final answer is, I want to typecast that to an int. Okay, so this is promising the compiler that it's okay if I lose data, just go ahead and make it an int, and that'll chop off the decimal. Okay, so then I just need to say if the width is less than 1, or I could have probably just said if it equaled 0, but I'll say if it's less than 1, then width equals 1, right? Just make it 1. Okay, and then it's pretty much the same process for height. We can just say the height is image.getHeight times the scale factor, and if the height is less than 1, make the height 1. There we go. Okay, so then now I've got the width and height that I want. I'm going to say image.scale. Okay, so that I call scale on the image that was the image of the actor. Okay, and I pass it the width and the height. There we go. Okay, so this is what I'm going to do when I apply this effect. If I remove the effect, the idea here is that I'm going to undo anything that apply did. So in this case, undoing what apply did involves scaling it back the opposite way. Okay, now the way I'm going to do it is a little bit quick and dirty, and you're going to see that it's not going to be perfect, because when you scale things, you're explicitly losing information because you're not storing all the pixels, right? If you have an image that is 100 pixels by 100 pixels, and then you scale it down to 50 pixels by 50 pixels, there's clearly a whole lot less pixels in the scaled down version. So therefore you've lost data, right? So if you were to then try to scale that same picture back up to 100 by 100, you would only have as much data as you had with the 50 by 50, so it's not going to look exactly right. Now there is a better way to do this, which would be to save the original image, and then make remove essentially set that actor's image back to its original image. That might be a better way to do it. However, it's a more complex way, and right now I just want to get this working, and that's not the point of this demo. So let's stick to the point here. So I'm literally going to just take that same code that I wrote here where I get the list of actors, I go through each actor, and the only thing I need to change here is I want it to be the inverse of the scale factor. So I'm just going to say 1 divided by scale factor. Okay, and literally that's the only thing I need to change. Okay, and multiplying by 1 divided by, that's really just, could just say divided by. It's probably better. Okay, so multiply by the scale factor and then divide by the scale factor if I want to reverse it. Pretty simple. There we go. Okay, so let's look at how this would work in action. So if I go back here and I open up the My World class, I think that a nice way to make this visual just have this habit of like cleaning up all this stuff because I like it. You can just focus on what's needed. Okay, so in here, what I'd like to do is that I want to make the world wait for a little bit and then apply one of these effects. So let's do this. Let's make a counter. And this is going to represent like, I'll even call it num frames, right? So it's like how many frames has the world been running for? And in the constructor, I'll initialize it to 0. And then every frame, so to make the world do something every frame, I can say public void act, right? And by doing that, I'm overriding the act method in the world, right? So every world has an act method, okay? It explains it right here. Every frame, it calls act, like the Greenfoot system calls act on the world, along with calling act on all the actors in the world. And by default, it does nothing. It should be overridden, so it's fully expecting you to override this method. Okay, so in here, I can say increase num frames. Okay, and then I'm just gonna say if it's been 200 frames, then I'm gonna make this scale effect. So let's do the plan here. Make scale effect. Okay, and then a little bit later, if num frames is like 400, okay, so 200 more frames, I'm going to, this is make scale effect and apply it. Okay, and then this one is going to remove the scale effect. Okay, and I want these to be the same scale effect. So in order to do that, since every time we call act, this method is going to start over, right? So if I just made a local variable here, it's not going to remember it across acts. So I'm actually going to make another instance variable that is going to be a scale effect variable. Actually, you know what? I'm going to make this a world effect variable, which will mean that it could be a world effect, or it could be any subclass of world effect. Okay, so that's going to come in handy later. Okay, and then let's call this effect. Is like the current effect. Okay, and so then let's do this. After 200 frames, we're going to say that world effect. Okay, where am I typing here? That world effect. Oh, whoops. That world effect that's named effect is going to be initialized to a new scale effect. Now, you might be wondering, well, how can I make a scale effect if I'm storing it in a variable of type world effect? And the reason you can is because you can see here that a scale effect is a world effect, right? So that's what this arrow means here, okay? Because a scale effect extends world effect, okay? So when we say scale effect extends world effect, that means this is just a more specific type Okay, so that means I can make this world effect be specifically in this case a scale effect, and I need to pass it the world that act was called on. And remember, the keyword this refers to this world, the one that act is being called on. So that's what I need to pass for the world, right? So remember, the scale effect takes a world and then a factor, right? So let's pick a scale factor. I'm going to go ahead and actually make it somewhat random. Actually, first I'll make it hard-coded to 0.5. Okay, and then later I'll mess around with that. Okay, so scale effect is going to be 0.5. So it'll basically make each image half as big. Okay, so then when we want to remove the scale effect, then all we need to do, wait, whoops, we didn't actually apply it. So to apply the effect, I need to say effect.apply. Okay, and then this is important. Notice that I can call apply on anything that's a world effect, right? And it knows it's gonna have that method, okay? And the scale effect defined what apply does right here. Later, when we make another world effect, in here, I don't have to say, or so I don't have to know when I'm calling apply here, I don't have to know what effect it is. It will apply the effect automatically, and it will know what type it is. Okay, and so then I'm going to say effect dot remove to remove it right here. Okay, and let's try that. So just to give you an idea of what this is going to look like. Okay, so to do this, I'm gonna have to make some actor classes. I'm literally just gonna like make random classes. Let's see, let's do butterfly. Sure. Okay, so butterfly, and they're not even gonna have any code other than just, I mean, all they're gonna just have it do is be different images. Okay, cactus. Make one more. How about baby? Okay. So none of these actors, they all have this default code that doesn't really do anything. So they're just gonna sit on the screen. But if I just hold down shift, okay, so I clicked on baby and then hold down shift, I can click on around the screen while holding down shift, and I can place some cactuses. Or you could just say new cactus, right? And then drag it here. That works too. Okay, so point is, if I hit run now, it's gonna wait a few seconds, and then boom, it applies, waits a little bit longer, boom, applies again, or removes, sorry. So notice that when it removed, so after applying and removing, you'll see that the image quality has been greatly reduced. And that was because of what I said before, you're literally losing data. Okay, so let's look at what happens if we make another kind of world effect. So this one, I'm gonna make this H flip. Okay, and my idea here is that an H flip effect is going to horizontally flip where things are on screen, right? So if this was the original screen, it's gonna flip these objects to the opposite sides across the middle here. So, so basically, the end effect would be that the square would be here and the triangle would be here, right? Okay, and that's because, so the triangle was originally like this distance, the x coordinate was like right here. So to do the horizontal flip, I just need it to be that same distance, but away from the opposite edge, right? And that's how I'm going to do the H flip. Okay, so let's go ahead here and do this. So in H flip, first delete all this nonsense they wrote. In fact, you know what? I'm going to delete everything. So if we're starting from nothing, what I need to say is public class H flip effect, and then it needs to extends world effect. Okay, and then the H flip effect isn't really going to have any instance variables. You either do it or don't, right? Like there's no variation on it. So I don't need that. I'm just going to make a, I'm going to handle this issue where it says, hey, I need to add these abstract methods. So public void remove, I declare the remove method, and public void apply is what's going to apply the H flip effect. And then of course this error saying that I need to have a constructor. So I'm going to say public H flip, whoops. Why can I not type H flip effect? And then it's got to take the world, but it doesn't have to take anything else. I can just call, so if I go to world effect, remember that this one takes a world. So all I have to do is pass world to that super constructor, right? Okay. Right. And then it's going to say, oh, I don't know what world is. So we got to say import Greenfoot dot, I'll say dot star. Okay. So then to apply HFlip, we need to get the list of actors. So remember we said list actors equals get me the world and get objects in that world of type actor.class. And I need to import java.util.list so that it knows what I'm talking about when I say list. Okay, and then for int I equals 0, I less than actors dot size, right? So for every index in the list of actors, we're going to get the actor. Okay, and then whoops. And then we need to set the X position. Okay, so there is no like set X or set Y, there's just set location. So we can say set location, and we want it to be whatever the previous X was. Let's draw a picture here. So if this was where the image was, or if this is where the actor was originally, this is X, this distance is X, then we want it to be that distance from the other side, right? So we can say set location to get me the world dot get width, right? The width of the world minus a dot get x. In other words, the x position of the actor. Okay, and then we want the same y. So we say a dot get y. Okay, so we're setting, oh right, and we need to call this on the actor. So a dot set location. Okay, so we're setting it on the actor. We're getting the world, get the width, and subtract the x of the actor, and we keep the same y. Okay, so that's it. So remove, one kind of cool thing here is that remove basically just needs to do it again, right? Because if we did h flip and then we did h flip again, then it would just, if it went from here to here, then if we did it again, it would go from here to here. Okay, so that's pretty cool. It like undoes itself. So that means all we have to do in remove is just call apply. Isn't that kind of funny? So we just literally like apply it again and that removes it. Okay, so that's it for HFlip, right? We can go back to our My World, and I think it would be pretty cool if we did kind of a random effect. So after 200 frames, we're gonna actually pick a random effect. We're gonna say if Greenfoot dot get random number. So remember we've used random number enough that I think you know how this works is basically we pass it a number. Like if we passed it 2, then it would pick a number from 0 up to but not including 2. So that would be 0 or 1. Okay, so if I said if that equals 0, that's going to be true 50% of the time. Okay, so if it's a 0, then we're going to do this, right? We're going to make a scale effect. Otherwise, we're going to make an H-flip effect. Effect equals new H-flip effect. And again, we just need to pass it this world, okay, but there's no other parameter. So this is pretty cool because look at this. When we say effect.apply, we actually don't know whether we're calling apply on an H-flip effect or a scale effect. It could be either one. But we don't have to because effect is just a world effect. So then we know for sure that it will have an apply. And because of how polymorphism works, polymorphism is the idea that you can call a method on an object and the object knows what type it is, so it does what that type of object does, right? So if we call apply and it turns out that it's an H-flip effect, it will run this code. If we call apply and it turned out it was a scale effect, then it would run this apply, right? Because it knows what it is. So that's pretty cool. All right, and then no matter what, when we say effect.remove, again, it knows what type it is, so it does the right kind of remove, right? Whatever remove goes with the type of effect that's currently on the world. Okay, so let's go run this program and see how this works. So I'm gonna put a bunch of actors on here. Okay, if I hit run, I don't even know. It could make them smaller and then larger, or it might flip them. So let's see. Hit run. Okay, it made them smaller, so that means it's gonna make them larger again. Good. Okay, and then if I reset, I guess I have to keep adding things. So let's just really quick again. Okay, if I hit run again, let's see if we get the other one. Aha, this time it was H-flip. And then it flipped them back again. That's pretty awesome. Okay, so hopefully this was helpful in understanding both how to make abstract classes, but also how to use them and how to design a system using abstract classes and subclasses, and maybe you learned a little bit more about inheritance and polymorphism. So that's the end of this video. Goodbye.